Now let's see how to use a graph to determine whether a function is increasing, decreasing, or constant. Before we come back with this example, let's look at the definition first. Okay, so we move 2 more slides down. All right, here's the definition about the increasing, decreasing, and constant. A function f is increasing on an open interval I if for any choice of x1 and x2 in that interval I, with x1 less than x2, we have f of x1 less than f of x2. Okay? So what that means, we can look at the next graph. So in an open interval, okay, so that's why these 2 endpoints, they're open circle, not a solid one. Okay, that means not included. All right, and then this blue curve represents the graph of a function. If randomly, okay, choose any 2 points on the graph, and then x1 less than x2, so this is x1, right? x1, y1. This point is x2, y2. Okay, remember y1, it is same as f of x1, right? y2, it is the same as f of x2. We learned that from the earlier section. Okay, so that means as x move from left to right, which is as x increase, and then the y, okay, from here move to here, you see the y coordinates, okay, is also increase, right? Y coordinates also increase. So as x increase, y also increase. This kind of correlation, we call it function is increasing. All right? So now let's look at the decreasing. Very similar kinds of definition. A function f is decreasing on an open interval I if for any choice of x1 and x2 in the interval I, with x1 less than x2. Okay, so this part is all the same as the previous increasing definition, and the only difference is the last sentence. We have f of x1 greater than f of x2. See the opposite. Okay, so this time the decreasing, still open interval, and then we randomly choose 2 arbitrary points on the graph. Okay, still x1 on the left-hand side of x2. So as x increase, right, from x1, from this point move to this point, x is increased, right? What about y? See, from here to here, vertical direction, right? And then the function is decreasing, right? So as x increase, y decrease. So this is kind of inverse variation, right? We learned the variation before. So you can kind of use that to help you understand the decreasing. Okay, and the constant is more simple. A function f is constant on an open interval I if for all choices of x in an interval I, the value f of x are equal. So let's look at the next slide. Still open interval. Okay, any 2 arbitrary points on the graph. Okay, x1, x2 can be any number, right? But y remain the same. All right. So as x increase, y stay the same. So from graph point of view, increasing, that means the graph going uphill. Okay, decreasing, the graph going downhill, and a constant is a horizontal line. It's kind of similar as how we, define the line increasing, decreasing, and a constant. The only thing different now in an open interval, it's not a straight line. Okay, it's a curve or the function graph. All right. So with that definition in mind, and then let's look at the example. Okay, how can we determine where function is increasing, decreasing, or constant? So when it's asking where, that's asking x from where to where. Okay, determine the value of x for which the function is increasing, decreasing, constant. So you need to, give the value of x. So in order to help you, determine increasing part, decreasing part, constant part, let's just use our pen to go through this graph, okay, from left to right. And then in that way, you can easily see whether it's downhill, uphill, or constant, right? Okay, let's from the most left-hand side of the graph, okay? From here to here, what do you think? It's going downhill, right? As x increase, and then the function decrease, right? So this is downhill. And then from here, this point, to here, and then keep going until here. Right, those same trend, right, going uphill. Is that right? And then from this point to this point, there's a horizontal line segment. So that's a constant. And then from this point to this point, what do you think? Going downhill, right? So that's decreasing. All right, so 2 segment is decreasing, right? From here to here, and then from here to here. So now let's find the x value, okay? This point to this point, what's the corresponding x coordinates? So it's from -4 to from -6 to -4, but the interval is open. Remember definition about increasing, decrease, constant. It must be an open interval, right? So you can also write into set notation. This is interval notation. Okay, you can also write as a set notation or write as inequality, like -6 less than x less than -4. Okay, or set notation x bar -6 less than x less than -4. Okay, those are all represent the same thing. Okay, that's one part decreasing. There's not done yet, right? There's another part decreasing from this point to this point. So x coordinate 3 and 6. So that's union. That means and. Okay, union 3 to 6. So here and 3 less than x less than 6. Okay, and here not close this parenthesis. Actually, and 3 less than x less than 6, and then close the set notation. Okay. So that's the decreasing part. Increasing only one section, which is from this point to this point. So increasing, so this is the decreasing. Okay, I just write a symbol. You know what I mean. Increasing is from -4 to 0. Okay, open interval. If write as inequality, that's -4 less than x less than 0. If you want to put a set notation, that's variable x, write a condition less than 0, close braces. All right, constant term, that's the line segment, okay, horizontal line segment from 0 to 3, okay, from 0 to 3. So that's a constant. I just write a horizontal line, okay. If you want to write an inequality, that's 0 less than x less than 3. If you want to write a set notation, variable x bar 0 less than x less than 3. Okay, so that's how to determine a function is increasing, decreasing, or constant from its graph. And you can look at the solution again. Okay.